Thanks everybody for spending some time after work. It's a beautiful day, and I know, oh my gosh, the screens in the back are working too. This is good. If you are not QR coded out yet, you should absolutely join our Discord community, or maybe not. Maybe you don't like what we're talking about, and then you can forget about it, and that's cool. But if you like it, you can join our Discord community. The link for it is most easily consumed with that QR code. So thank you for taking some time after work. This is a session where we're going to walk through some code. We're going to walk through some stuff together. You can do everything I'm doing along with me if you want to. So I think I'll leave it with that. Okay.
Where's the code?
Where is the code? I mean, goodness, that's a fantastic question. Let's see. Can you guys still hear me? Tempting fate by bringing it closer so I can type while talking. Does that work? Do I have to, can you guys still hear me, or do I have to get closer? Oh, okay. Well, we're just gonna see. We're gonna see how this works. Maybe I bring the laptop over here. Oh, okay. We're getting close. Okay, so I've got to fix one more thing. Everybody's looking at this. I got to figure out how to get you to, let's see. Where is the code? When we get to that, I will show you where the code is. How's that? All right. So hello, I'm Rajat. I'm a co-founder at XetHub. I've been a software engineer for a long time. And I've spent the last 10 years or so building systems to support machine learning. I would love to know a little bit about everybody here. So show of hands, how many folks here are ML engineers? All right. How many are software engineers? All right. How many are executives? We already met a couple VCs, so we know you're here too. Anybody else? Other roles that I'm not capturing?
Data engineering.
Data engineering, okay, very cool. Well, thank you all for taking the time. It's great to get to know you all or get to meet you all, and hopefully we get to talk more. I'll spend a second telling you about XetHub. We are a Seattle-based storage and collaboration company focused on building a platform to enable teams to collaborate at scale. We're seed stage, funded by Madrona, who some of you may know is a venture capital firm based in Seattle. There's 18 of us now, which is pretty awesome. And our headquarters is in Seattle, downtown in the beautiful neighborhood of Fremont, right along the water. We leased some space from our friends at OctoML. And if you have been to that space, it's really nice. I'll spend 1 minute talking about XetHub. Where do we fit in this giant Venn diagram of ML ops? I think we fit here. And I'll leave you with like 3 little taglines, and you tell me if you like any of them. So XetHub is for rapid machine learning model iteration. XetHub's like GitHub, but for data and models. And XetHub's like LakeFS, but so much faster. Okay. I'd love for this to be an interactive session, so please interrupt with questions or raise your hands. It's the end of the day. There's only so much talking I can do without people making this interactive. So please, please, please. We'll start with a quick demo so you can kind of see where we will be by the end of today's session. And then I'll break down the overview of a generative AI app, a little bit about the tech stack involved, and then we'll go build the app ourselves together. All right, here we go. Start with a demo. So I'm going to break out a PowerPoint, which is always a little nerve-wracking. All right, everybody can see my screen. Is this big enough? Can you guys kind of read what's going on? There's a thing that says My GPT. Well, that's what we're going to build. And so what we're building is a chat bot or a ChatGPT-like system that can answer questions about our documents. But I haven't told you what this application has been, what data it's been tailored with. So this is tailored with one of my hobbies. I like watching movies, so I have a movies data set. And so we can ask nice trivia style questions over movies that have come out in the last 50 years or so, from 1970 to 2020, and it'd be great to start with one from the crowd. Or maybe I'll come up with one, you guys think of the next one. Let's see, did Chris Pine play Captain America in Captain America? So what I'm showing you is we're going to end up building ourselves. So this gives you kind of a flavor of what you're going to get at the end of today's session. Well, Chris Pine did not play Captain America. Why is that? You guys know? Because it was another Chris. Not Hemsworth, because he's Thor. Chris Evans. Okay, next question. This one's got to come from somebody else. And if you want a sense of our data set, I'll go over to XetHub where this file exists, and we'll go take a look at movies.csv. And what you'll see is we have a quick summary on the top of the file. So it's a pretty big file. It's, 24 megabytes in size. So it's not really fun to look at each row individually, but you can see things like, oh, the release year. Oh, I see. Okay, so my data set kind of goes from 1970 to 2020. Oh, these are the genres. Oh, look at that. There's more films in the drama genre than any other. I never knew there was a drama romance genre. I didn't know that was one that existed, but now I do. And you can see the other columns are the director, then a plot summary, and the cast. So you kind of have a flavor of what's in this data set. And before I jump off this tab, I want to point out one other thing. Why do we need a system like XetHub to build generative AI apps? Because even this toy example where my data set is 24 megabytes in size, the overall project is 16 gigabytes on disk. But stored with XetHub, 5.2 gigs. So that's one of the reasons why you need to have a system that scales Git in order to work on machine learning projects or generative AI applications.
So the 16 gigabytes, that's the weight of the model.
Ah, good question. So the question was, are the 16 gigabytes the weights of the model? Well, as we're going to get to in the slides, the answer is not really. It's the embeddings. Because the model doesn't change because it's a foundation model. But that's a great question. But we're back to movie trivia. Who's got the next question to ask? Go for it, Eugene, in the back. Yell it out.
Who's the director for The Usual Suspects?
All right. Bryan Singer, right?
I don't know.
Okay. Dun, 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 dun. The director for The Usual Suspects was Bryan Singer. All right. Oh, wait a minute. I have things to give out. I totally forgot. This is why none of you have questions. None of you have trivia stuff. I forgot all about the swag I have. Hold on. This will work. I have some pretty fancy stickers and some even fancier ballpoint pens, just not the black one. That one's not very fancy. So I will pass this back. You guys will all get this to Eugene, I am sure. Who's got the next question?
I will.
Okay. Okay, thank you.
I'm curious, who plays the kid from Love Actually?
All right, the question was, uh-oh, I closed my window. Oopsie. Control-Shift-T, let's do it. Oh, well done, thank you. Who played the child in Love Actually? Is that right?
Yes, sir.
All right, let's see. I've not seen this movie, so I actually don't know this. Oh, the child in Love Actually was not mentioned in any of my sources.
It's a good movie, though.
It's a good movie? All right, I will buy it. Other questions?
This would be a fancy one, but did Indiana Jones kill Darth Vader?
Okay, unless it's in the plot, I doubt we're going to get that, like the plot summary, but we'll try it. Indiana Jones kill Darth Vader. It's so dark. Let's see. No, Indiana Jones did not kill Darth Vader.
Can you ask the other way around?
I can certainly ask the other way around. All right. Did Darth Vader kill Indiana Jones? Dun, 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 dun. Nope.
What about, did the actor that played Indiana Jones kill Darth Vader?
There we go. The actor that plays Indiana Jones killed Darth Vader. No, the actor that played Indiana Jones, Harrison Ford, did not kill Darth Vader. That seems right, right? That's in Star Wars. That's right, right? Okay. Wait, there was another one. I think you had your hand up.
Yeah, I'm gonna change my question. Did Han shoot first?
Did Han shoot first? Did Han Solo shoot first? Oh boy. I don't know. I don't know. I feel like that's a pretty good answer. Let's see. We could, instead of just asking sort of trivia questions, did this happen? Did that happen? Sometimes you want your assistant to do something a little bit more powerful, your AI assistant. So let's have it do something for us. Write a friendly message. Write a message to a friend, encouraging them to watch all Star Wars movies in order. Mention the significance of Star Wars and make the message funny and include a few emojis.
What's it going to do about release order versus chronological?
Yeah.
I have no idea. We're going to find out. I have a feeling it's going to use release order because that's what's in my data set. Hey, friend, if you're looking for a movie to watch, why not watch all the Star Wars movies in order? It's a classic saga with themes of loyalty, friendship, revenge, and more. Plus, the special effects are out of this world. Trust me, it's worth it. So you don't have to write text anymore. By the end of tonight's session, you can have the system generate these for you based on things that are important to you. So this was a good sort of preview. Any other questions you want to ask this version of MyGPT before we move on?
So are you tied into the real OpenGPT or?
Yeah, so this is actually using the DaVinci text model that from OpenAI. That's the same model that's used in ChatGPT. And I'm going to tell you how we do that in the next bit, how we build this application. If you want to do this all on your own, it's not the thing we're going to work on tonight, but you can definitely go to ZetHub, Rajat Arya, LangChain_movies, and this is the exact app that I'm showing you right now. So you can try this out and ask other questions about movies. All right, we're going back to slides. And all right, we did that. So the next thing, I want to give you a kind of a quick overview of generative AI.
When did you guys start?
I'm sorry, say it again.
When did you start your company?
When did ZetHub start as a company?
Yeah.
Yeah, February 1st, 2022.
Okay. So before AI was cool.
The follow-up to that was before AI was cool, and I will, my response is, I mean, is AI cool? Like even now?
More than.
I don't know. So most of us, many of us that joined that are part of ZetHub were part of a machine learning startup 10 years ago called GraphLab, and then Dado, and then Turi. And we got acquired by Apple back in 2016. So I don't know, that felt like the original hype cycle for machine learning was 10 years ago. So this feels like a different thing. But nonetheless, about generative AI. It's certainly in the news a lot, but really this is just a recent category of existing machine learning technology. The main difference is these ML models are so big that their predictions generate new content. And in that way, they can seem more intelligent than they are. And that's what makes generative AI feel like a new thing, but it's not really all that new. Now, what makes up generative AI? Generative AI relies on machine learning models, a class of which are called foundation models. And these models are all neural networks, and the only thing that makes them foundation models is that they are gigantic, 100 billion parameters or more. And the reason they end up getting called foundation models is because they're so big that they can adapt new information that you provide them with what they've been trained on to generate an output that seems novel. And so in a way, they feel like they're foundational on which you can build other things. And that's exactly what foundation models end up being used for. You can fine tune them to specific use cases. Or what we'll do tonight, which is tailor them to a data set of our choosing. Now, foundation models, there are different types of foundation models for the different use cases, for the types of data that you have. So you've probably heard of large language models. So LLMs are for text-based use cases. So we're going to use an LLM, the OpenAI DaVinci large language model. But there are other foundation models for audio, for images, for video. So just keep that in mind. So this ties into the question that was asked earlier about, are you using OpenAI's model for this application? So it kind of looks like, so I'm going to walk through what's actually happening when we run this app and how it's built, and then we're going to go do it. So it looks like there's a form on the screen, and you hit submit, and we must send a request off to the DaVinci model, which is like a fancy service in the internet somewhere, probably running on Azure, and then it comes back with a response. And that's it. That's how it works. But that's not it. That's not actually how it works. So the key thing to remember, there's a couple things about foundation models that are really important. And if you take away nothing else, take this away. Foundation models do not change. They have been trained once on massive data sets, typically in an unsupervised or semi-supervised way, and they're fixed. The model itself is not changing. But, as I mentioned before, they're so large that they can learn context and relationships. So if we're thinking about large language models for text, they can learn context and relationships of how language or how text is constructed and interpreted. And because the models are so large and can learn context and relationships, they excel at manipulating existing data, taking in new data, and generating an output accordingly. So far, so good? I mean, there's a whole lot more depth that you can go into about this, but I feel like this is the primer that is really important. So if the foundation model is not changing, then what's actually happening when I click submit? Well, what's happening is we take the input string and we send it off to a different service. In this case, it's another OpenAI service, the text embedding service, which takes our input string and turns it into a vector of floats, often called the embeddings vector. And what this allows us to do is to do a query to find semantic similarity over our data, to then see which documents from our data set are most relevant to the question or the input that we're trying to answer. And so we make that query against our embeddings vector database, get back the relevant documents, and these are, when I say documents, I should clarify, these are document fragments. So it's not necessarily the entire document, but it's likely the section of the document that's relevant, semantically similar, using a distance function between the input vector and the embeddings vector, or the input embeddings vector with the document fragments embedding vector.
And these documents, are they sent back as like the documents? Or
So wait 2 seconds. So when we find the similar documents, we add those document fragments as context to the input that we started with, and now we construct a prompt. And you guys have all heard about how LLMs are driven by prompts. Well, the prompt is the input string and the relevant document fragments. So then you submit all of this to the big bad LLM, and it returns to you its answer. So in a way, what you're saying to the LLM is, hey, given all this information, answer this question. So foundation models are tailored to your data because the app submits the relevant data along with your input. Okay, what was your question?
Yeah, the documents, it became clear as you answered it. I was asking if they come in as vectors or the real text, but it seems like the real
So that's your perfect segue to the next thing I'm going to talk about. How do the documents that we use, my movies.csv file, how did that show up? How was I able to make a query against my embeddings vector database in the first place? Well, that's what I'll call our training step in building this application. We take the documents and we again call out to the text embeddings service from OpenAI, get back the vectors, the embedding vectors for each of these documents, and then we store them in our embeddings vector database. So to go back to the earlier question, why is the project so big? It's because we're checking in this embeddings vector database with each commit as we make changes to our data set. Eugene has a question in the back.
What's the vector database you're using?
So I love this segue because my next slide is all about the tech stack involved. So before we jump into the code and actually go build this, let me tell you the parts that what's the tech stack to build this up. So I talked about the services involved. We're using the DaVinci LLM. There are other LLMs out there, but I think for state of the art today is still the OpenAI ChatGPT LLM. We are also using OpenAI's text embedding service. You don't have to do that. You can use any number of embedding services. You can run them locally. I just happened to choose this one because it was easy to integrate, and so I did. Just keep that in mind. Question?
Do you have to have the documents embedding created by the same service that the query embedding that created later on?
That's a good question. It depends a little bit on how there's a little more subtlety there. So it depends on what you're getting from your embedding service, but the answer is no. Like you don't have to have it depends, but generally no. You don't need to have a pairing between the LLM and the embedding service. You can happily use a Hugging Face embedding sentence transformer embedding service locally and the DaVinci LLM.
So these embeddings are fairly absolute.
Yeah.
Okay.
Yeah. It's not. I don't want to say that there isn't complexity in all this because there is, and you can't sort of like hand wave it all away. But in general, that isn't a thing that I would worry too much about. Okay, so those are the services. Oh, go ahead.
Do you have a sense of the level of performance without the data fragments given to the DaVinci model?
So the question was, do I have a sense of the performance of the data fragments given without?
No, the input text sent directly to DaVinci without the data fragments. So what does the performance look like?
So the question is, what does the performance look like if you send the input text just by itself to the DaVinci model? So that I think is going to be pretty application specific because the DaVinci model was trained on like this, OpenAI doesn't tell you exactly, but assume internet text up until like the fall of 2020 or 2021, if I remember correctly, something like that. And so that all it kind of knows of the world ends there. And so asking it about specific events or time or stuff like that, it's unlikely you're going to get great information. But if you want to ask it something general, like, build me a travel plan or build me those types of things it can help with. But I think about this a lot in the context of like helping me do my job. So what sort of assistant do I want? So, my company only started a year and a half ago, so it doesn't know a whole lot about XetHub. So for it to know anything about it, I'm going to have to give it the data set. I'm going to have to tell it about XetHub. Question? Yeah?
How do you tell that it's answering the question from your embeddings and not from its general knowledge?
The question was, how do you know you're getting answers from the embeddings versus general knowledge? And I guess my response to that is it's telling you which sources it's using to give you the answer. So it's telling you which document fragments. Now, in my example, and so you'll see a little bit later when we build one where there's many documents, you'll get to see that working. But in my example, there's just one CSV file, so it wasn't as clear. Okay, so these are the services What about the code? That's kind of the fun part. We're all going to write that. I saw more hands for software engineers and data engineers than anything else. So let's talk about that. So all this code's written in Python. How many of you use Python every day? All right. How many of you use Python 3.7 or greater? Oh, thank goodness. Okay, good. Good. So all this code's written in Python, and everything that we're going to walk through, you can run yourself on Python 3.7 or above, as long as it's 64-bit Python. I don't understand how you can still get a 32-bit Python on Windows, but apparently you can. So the question that Eugene asked, what vector database are you using? Well, I'm using Chroma, and I know that's not the one that you work on, and I'm sorry. But I didn't want to swap all that out just for today. Chroma's been around for a while, but this is all these parts that are part of the generative AI app, they're all in flux and changing daily, maybe weekly if you're lucky, but almost everything is moving really fast. So you absolutely can optimize your vector database. You absolutely can optimize all the different parts of your application. But really, for me, it's all about getting something working end to end to begin with, and then see if the app's actually useful. And then you can go and make things better. But yes, I'm using Chroma for this example. It was just all part of the tutorial for getting things going that I was following, so it made it pretty easy for me. The UI is built using Gradio. If you've used Gradio before, it's a Python package that makes it easy to build web applications without having to write HTML, JavaScript, or CSS. It lets you build, reactive, interactive web applications really simply. I'll walk you through a little bit of the UI code. I mean, there's only a little bit of UI code altogether, and I'll walk you through it in a couple minutes. But the important sort of piece in the middle, the glue code for this application, is using LangChain. How many folks have tried LangChain before? All right. LangChain is a really hot Python package that's under a lot of active development right now. So almost every week, you're going to get a new version of LangChain. It's going to do more. But LangChain is the glue that connects whatever vector data, sort of abstracts the vector database from the LLM. So you can think of it as the separation of concerns between your store, your model, and your view. I don't know, I was trying to stretch the MVC thing, and I don't know if anyone still knows that design pattern. But the idea that it's what separates your vector database. It helps you construct the prompt to the LLM, and it supports sort of abstracting away different LLMs. So you don't have to change any other code in your application if you want to try a different large language model, or you want to try a different vector database. So that's sort of the power that the sort of piece that it fits in the stack. But that's not our whole project, right? Oftentimes we think of software projects as just being a bunch of code, but that's not true for generative AI applications. You've got your data, and you've got your model, or what I call the model in this application, which is your embeddings, your vector database of embeddings. So you need to keep track of all of these things, or else you can't reproduce your application. So to do that, we're going to leverage XetHub today, because XetHub scales Git, so you can have repositories of 10 terabytes or more, while maintaining the performance that you're used to, so you can build generative AI applications and keep track of everything in one place. All right, so before I go away from slides, any questions? Because the rest is code. Go ahead.
I'm curious, do you have any experience to share how you balance the limit of the context length as well as number of tokens you send to the OpenAI to control your deal?
Yeah, so the question was, do I have any experience with balancing context length for versus number of tokens to submit and retrieve? So as you start using LLMs, so the short answer is sort of, but let me describe a little bit more. So as you start using LLMs, you realize that they have limitations. One of the big limitations is the number of tokens that they can generate, or the amount of context that they can interpret. And so there is a balancing act of how much am I going to ask to generate in my response, and how much information do I need to provide in order to get that response. And I think I think this is more art today than science, and so it's more of a trial and error depending on your use case, depending on your application. from my experience, LLMs are not very good at counting or doing analytics work. And so, but they're fantastic at text summarization, text generation. And so it kind of, this is a thing that's worth experimenting with and trying. All right, out of slides. How am I doing on time? All right, I think I've got like 10 more minutes or so. Is that right? Somebody tell me I'm okay on time. Eugene, how much time do I have?
I think you're okay on time.
I'm okay on time. He says it, I believe him. All right. What did I say we're doing? Okay, so we are going to go and build my GPT. And so this is where I said before that when we get there, I will pass along the URL. So you go to XetHub and you go to Rajat Arya /my-GPT. Everybody see it up here? It's right there. Okay. And if you don't want to do it right now, it's totally fine. You can do it afterwards too, because you can just go to XetHub and do it. And what do we want to do whenever we see a project we want to work on? Well, we fork it, right? Isn't that what we do? All right, so we're going to fork this. And we're going to call this my GPT demo. And because I'm the owner of the original one, it's going to change the ownership for me, which isn't as awesome, but don't worry, I'll change it back. You won't even notice. So now I'm going to go into my settings, and I'm going to go down to this danger zone area, and I'm going to transfer this new owner back to me. And so now it's back in my account, and then I'm going to do something that GitHub doesn't let you do. So if you take a public repo on GitHub and fork it, you cannot make it private. But of course, you guys don't want to put your data in a public repo. So just convert it to a regular Zet. And what does this do? Well, this will break the parentage with the fork. So now you see up here, it's no longer parented off of the previous repo. So now it's like a brand new repo. And any brand new repo, I can go and make private. And now you see my repo is private. So just like that, we've got our own copy or clone, but really not the clone because that's a very specific thing in GitLand, but we've got our own version of this project ready to go. So what do we do next when we've got a repo and we want to start working on it? Come on, you can all say it out loud together. What do? We clone it, that's right. So we'll copy the clone command and we'll head over to the terminal. Make this a little bigger. Can everybody see the screen? Can anyone read the text? Yeah? Okay. So we'll go into my Zets directory and we'll run git zet clone. Why is this not git clone? It totally could be. You could run that. But in order to use XetHub, you need to install a Git extension, and it only takes a second. When you click on our quick start, you'll go to install and setup. You'll click a button to download it for the platform that you're on. You'll create a personal access token, and you'll copy and paste a line into your shell to set your machine up to authenticate back to XetHub. And we need to do this because this is how we manage the repos as they get bigger and bigger. So this is a key piece to allowing the repository to scale. But I've already done all that, so we don't have to do that together. Let's see. So here we go. I've got my repo locally, and let's go into it. So this is just a Git repo. You can do whatever Git you want to do. I'm on the main branch, and there's nothing going on. My branch, there's no untracked work. That's why my shell is showing this nice yellow color. And so, I'm ready to put data into my project. So what I'm going to do is I'm going to kick off the training step, and then I'm going to do a quick code walkthrough on the code. So you get a sense of how this app is built. And then we'll come back when hopefully we're done with the training step, and then we'll see what that running app actually looks like. So what do I need to do to, so what do you need to do if you start with this MyGPT project and you do the same steps I just did? All you have to do is drop your data into the data directory and then kick off the training step. So you'll see if you look at the file system layout, there's a data directory, a model directory, and a source directory. The other thing is you have a requirements.txt for setting up your Python virtual environment, which we'll do in just a second. Actually, we'll do it right now. So we're doing Python. So let's create our Python virtual environment. I'm realizing, why don't I do this? Because I realized when I was sitting in the back, no one can see the bottom of the TV, so maybe I'll type that here. User bin Python 3, and we'll create the virtual environment right here in this directory. And then let's activate it. All right, and now let's install our requirements. And just to show you, the requirements file is really pretty small. There's not a whole lot in there, but you can see we've got ChromaDB, Gradio, LangChain, OpenAI's Python API, and a couple others just to make life better. Hit install -r requirements. Oh, I missed an L. No one caught me, guys. Come on, no one's paying attention. Luckily, I've got all this cached on my machine. I've done this before, so it shouldn't take too long. But again, like I said, in the generative AI app space, these packages are updating all the time. And so there's nothing to say that if I ran this an hour from now, there wouldn't be a couple Python packages that need to get downloaded. This is familiar to everybody? Everybody who raised their hand saying they use Python on a regular basis? Kind of going through this loop? All right, so here we go. We are installing these packages. Okay, all done. Now, all I have to do to be able to kick off my training step is copy in some my source data or my data set into my data directory. Well, lucky for y'all, I've got my data right here. So I'm going to copy it, I'm going to paste it. It's really not going to take too long because it's just an export of a section in Notion in our Notion workspace. So now I've got my data is there. So now what do? Actually, we run Python source train. And we cross our fingers that it all works. Oh, wait a minute, it might not work. One more step. Sorry. We've got to make sure our OpenAI API key is that environment variable is set, or else we can't call the embedding service because OpenAI won't know who to bill. By the way, everything that I'm showing you today shouldn't cost you any money because OpenAI gives you $20 worth of credit every month. And what we're doing with this is pretty small, but just keep that in mind. And that $20 a month this is unrelated to ChatGPT. This is using OpenAI's platform or using their services. All right, I said I was going to show you the code while this is building. So let's do that. So the code is organized the way you'd expect in a source directory. There's just a few files. So the UI code, let's see, what's the easiest way to kind of walk through this? Let's start with the UI. I guess we go 6 of one, half dozen of the other. Let's start with training, because that's what we're running right now, and then we'll work our way up to the UI. So I'm going to click on train.py. Did I click on it? There we go. And you can see this file's not doing a whole lot. I'm not going to read Python code to you, but you can see it's essentially calling index.fit. Well, then what is index? All right, let's go click over on index. Index is where all the heavy lifting is happening in this application. So this is what's building the embedding vector database, and and then it's what's managing how we process our input documents, turn them into document fragments, go and get embeddings for them. That whole piece of you can think of the index class as the object that's responsible for managing and maintaining the index over your embeddings. You can see this guy pulls in all the LangChain stuff, and there's a whole lot more LangChain stuff. But for this application, I'm just using the text loader, which handles text files. But there are other document loaders for other file formats. And so lots of knobs you can tune and configure here. What are we doing? So the index class has a few methods that are useful. The load method is what will happen once we've trained, and when we're running the application, we want to load our index off disk. We don't want to have to regenerate it. But when we call fit, which we saw train.py is calling, all that's doing is deleting the old stuff that was there, if it was there, setting up our LLM to OpenAI, and then calling build vector store, which is defined right above it. See how convenient that is? And all this is doing is iterating through all our docs with some pretty gnarly Python code to generate document fragments, and then going off and getting embeddings for those fragments and storing them into Chroma, which is our vector DB. Okay, so that's how we do our training step, and you saw the load method, which is how we load our index or our vector DB when the application is running. But I haven't talked about how the UI works yet. So let's go into the UI code, which is Gradio, and you can see it's like writing all sorts of HTML where it seems so easy. And so I've got like a really basic UI where I'm defining HTML tags, but they're organized in blocks with rows and columns. So this way I don't actually have to think about layout all that much. And then I've got the power is I can do things like this is a text box, and it should be available, it's visible when you've got your data and your model and your OpenAI API key, so that it does some validation that things are working, shows the image, and then has the interactivity between submitting the form or clicking the button, and both of these end up calling this function called helper question and answer, passing in the question and showing, and then wiring up the output field that should get the response. So what is helper? This is the last thing I'm going to show you, because walking through code is not the most fun. But question answer is really a simple thing. It takes the question and it goes off and calls query, which is a function, a method of our index. Remember the index class? It's a method of that. The index had the fit and the load. It also has a query method, and then takes the response from the query method and breaks up the sources that, meaning the document fragments, and reformats them so that they look a little nicer in the UI. So far, so good. Obviously, you have to look at this code and spend a little more time with it to really digest all of it. But the basic thing to take away is index.py is doing all the work, app.py is the UI, and that's more or less it. The rest is all kind of stuff that's needed to make it all go. Let's go see if we're done training. We're done. We were actually done in 82 seconds, but I talked for a little longer than that. So now let's run the app. You guys don't know what we built because I didn't tell you what this data set is. I just said it was an export from Notion. Let's see. So to run it, I just run Gradio source app. Oh, wait, hold on. For everybody in the back that can't see the bottom of the screen, we'll do that again. I run Gradio source app.py. And what this is going to do is call that load method on index, and you can see what it pulled up. There are 2,299 embeddings, which are captured in one collection. I haven't talked about collections. I wouldn't worry too much about them, but you can have multiple collections as think of them as namespace type things in your vector database. A lot of hand waving. Okay, and now it's saying that this is running on this port. Let's do it. So we could just ask, what are these docs about? Or for the interest of time, I'll tell you what these docs are. These docs are the marketing section of the Notion workspace for XetHub. So I told you I really like these assistants helping me do my job, and a lot of my job is talking with teams and engineers and encouraging them to use XetHub. So we might as well have the system do that for me. So we're going to ask, write an email to an ML engineer, encouraging them to try XetHub. Make sure to include the top 3 reasons to use XetHub. Top 3 benefits, maybe is a better word. Benefits to using XetHub, write a catchy, because nobody reads emails unless they have a catchy subject line. Make the tone of the email friendly and casual, and include 4 to 5 emojis. Does that look good? Does that seem like a useful thing? Let's see what we get. Last time I ran this, it led me to some pretty fun stuff. So let's see what we see this time. And this will go back to the previous question around how do you know where this came from? And so you can see the sources on the right are referencing a particular document. So Gather AI is a customer of ours that we wrote a case study about. And so this is one of the documents that was used in coming up with this. So let's see. I probably won't read you this whole thing, but I'll read a little bit. Boost your ML workflow with XetHub, co-founder's invitation. That's my invitation. During your next lunch break, give XetHub a try. Sign in with your GitHub credentials and spend 15 minutes with our onboarding tutorial repo. If you don't think XetHub will improve your ML workflow, email me, and I'll send you a Starbucks gift card. So there you go. I've got my GPT helping, having me help other Seattle businesses by distributing their gift cards to anyone that tries XetHub and doesn't find it valuable. So that's what I wanted to cover. Look at the emojis, they just shoved it. They got 1 in the subject and 4 next to my name. How do you take me seriously if I've got 4, I've got a hugging face, a smiley face, a laughing, and I don't even know the last one, emojis next to my name. Well, I'm not thrilled with this output. But look, again, this is one of those systems where it's not deterministic. So I can ask the same question again, and I'll get a different response. So maybe I don't like this, we'll try one more time. In the ChatGPT case, your context is growing with each response. So that's how you could say, hey, go correct the previous thing. Go ahead, there was a question in the back.
I think you answered it. If you refer to the document you just produced and say, reformat this in a different style?
You can. So the question was, can you refer to the document that was just generated and sort of have the LLM adapt based off of that document? The answer is yes. The way this code is written, it's not going to work out of the box. Essentially, what you're going to want to do is extend the way. Right now, this is using LangChain. What's it called? LangChain is built. You sort of assemble chains, and right now, when you hit submit, it's like as if a new chain is created. But that's where you want to adapt the code. So absolutely possible, just not the way this code is written today. All right, well, the second time around, this looks better. I've got whatever this emoji is in the subject and at least none next to my name. But there you go. Huge access to huge repository within seconds, easily collaborate with team members using familiar Git syntax, and you can enjoy built-in features like reviews, the summary diffs, version history, and variable block level deduplication. So there you go. So that's what I wanted to show you. In what, half an hour, we built a ChatGPT that's tailored on our data, and it helped me write an email to a set of ML engineers. And everything I've shown you, you can do yourself with, by going to XetHub.com. I didn't get a chance to show you this today, but we just deployed a new version of our open source Python SDK, which is called PyZ. So you actually don't even have to use Git anymore. You can just use Python, but get all the benefits of version control. So I didn't raise my hand earlier because I felt bad for Eugene having to run back and forth, but PyZ is an open source project. We haven't quite gotten all the code out yet. It takes a while to break a mono repo with Rust code and Python code and Golang code. And, we're on our way to get there. But we'd love for you to participate. And the easiest way you can get plugged into this is to join our Discord and bug me on Discord. Again, thank you for your patience and your questions. I'm going to be here after Kaushik's presentation. I'd love to chat with you.
Hello. everyone here. How everyone are doing today? Good, good.
Now that you're here.
All right. So I'm Kaushik. I work as a senior data scientist at an edtech startup company called Ashram. Some of my colleagues are there. Yeah. So today I'll be talking about structured extraction. It's just a fancy term for parsing. So let's start the evening with a meme. How many of you tried regular expressions? How many of you heard regular expressions? Okay, so it's a very awesome job. You feel very excited when you do that. I'm just joking. So it's a tedious job. Basically, you need to write a lot of patterns to extract certain information from unstructured data. I've been attending a lot of talks and I've been seeing a lot of demos where people show generative AI applications using large language models. But I felt like, extraction is as important or probably more important than generation, because once you have data in a particular format, you can use it for generation or you can use it for specific businesses. So my motivation of today's talk is how we perform the extraction. All right, the agenda, I'll be talking about different types of data. Most of you know about that. And quickly talk about evaluation of unstructured and structured data. This is a controversial slide, so you will know when it comes. And I will also talk about why it is important to extract structured text from unstructured data. Then I'll go and do a quick demo, basically a code demo using Core. So Core is a library which is written on top of LangChain. So it's kind of like probably Keras for LangChain. It makes extraction easy. Then I'll be concluding and giving the takeaways from my experience with this library. So you all know there are three types of data: structured, unstructured, and semi-structured. Structured is like we have predefined data model. A classic example, everyone know that structured databases are nothing but relational databases, etc. Then we have unstructured databases. They don't have any predefined model. This can come in different formats. It starts from emails, medium articles, or PDF files, and much more. Then we have some interesting data type, which is like semi-structured. It has a data model, but it's not just straight. Classic examples are like XML JSONs, where the values can be arbitrary. It need not be fixed. So over these years, analyzing unstructured and semi-structured data is hard. So let's quickly look at the evolution of data. So yeah, I told you this is kind of a controversial slide because a lot of people don't agree, but basically I divided the timeline into 5 different eras, and these eras are not mutually exclusive. There is definitely overlap between them. Before 1940s, it's like pre-computing era where the data is collected, primarily stored in physical formats like paper, books, etc. Then comes computer era. This is where we have seen rise of relational databases, rise of internet. Rise of internet created a lot of user-generated content, but at the same time, rise of relational databases created a lot of business value for different applications. Then came big data era. We have been collecting a lot of data. Data is stored in distributed systems, and not just stored, but also processed in that fashion. slowly, once we collected data, we have seen a lot of value in analyzing them. That's where we have seen like machine learning and deep learning era. This is when cloud became predominant. At the end, we are now in language models era, like kind of started from 2018 from Word, but still like this today's talk is also focused on this era where how we can transform unstructured data to structured data. So over all these years, the significance of extraction has been increased. And why it is important to extract the structured data, right? Like we can get rid of chunk. Like who want to save the entire PDF where we don't want to use, like just have all the content of the PDF. This can help storage. This can help to save the cost of processing, etc. And also enhancing the data quality. It's very hard if it's if we have an unstructured data, how we can detect anomalies, how we can detect inconsistencies in them, right? I mean, if we can structure them out, then we can definitely find missing values or at least find what anomalies we have in them. Then comes the scalability, because data is in appropriate format, it can really scale them for companies. All right, so I'll stop. I know it's a Wednesday evening, so you will ask me to show the code and stop the talk. So let me go to the code. So as I mentioned, I'll be using core. Again, core is written on top of LangChain. It's explicitly used for extraction. Then we will be loading chat OpenAI model. Basically, I'll be loading GPT 3.5 turbo model, which is their current best model with the cost of 1/10 of DaVinci DaVinci 003. We will also look basically we will also look at the pydantic, how we can validate the structured information which gets extracted. So the second step is just to load the language model. Before that, I just also have loaded my key. The first step to extract any structured information is defining the schema. So this is how we can define the schema. There is an object structure. Can everyone see this object? Or is it too small? Is it fine now? So yeah, we can define the object structure. Let's say we want to extract the personal information from an unstructured data. You also need to provide the description, like what personal info means. Then this is the cool part. You can also explicitly mention the attributes, like in personal information, what you exactly want to extract, like first name, last name, and age. You just need to provide examples, and you can provide individual examples, and you can also provide the combination of attributes examples, so it understands what personal information better. And there is also a parameter called many, which basically means that this can extract multiple, like it need not be just one entry, it can be multiple entries from the text. Yeah, the second step is just to use the chain from core, which is actually using LangChain's chain. And the third step is just to predict the output. So here you can see Jim Carrey, my favorite actor, done 60, but he remains saying it hard. He looks like he's just only 25 years old. I'm just putting this thing so that we are trying to confuse the language model that he looks like 25, but what exact age is like 60, right? And I'm having additional text like his daughter is this and Tom is his pet. So we make, this is the personal information about humans. And we explicitly given an example when we are defining the object, like Bella is my cat, actually this should be Bella is my cat name, and we are saying that don't extract anything because it's a cat. And even in my initial description, I explicitly mentioned that it's about a person but not any pet. Yeah, so simple. So this is how you can run your code and get the structured information from the text. But we all want to know what's happening inside, right? Like what is this library and what it's trying to do. it is just trying to generate a prompt. So let's look actually the prompt it generated. So when we define the schema, this is the prompt that the library is generating. So it's saying that your goal is to extract structured information from user input that matches the form described below. When extracting information, please make sure it matches with the type information exactly. These models hallucinate, so we need to be explicitly tell these things like do not add any attributes that do not appear in the schema. It just converted my objects or attributes into TypeScript. So we have first name, what is the type of it, and the description of it. And then this is interesting. It have an additional prompt which also says that please output the extracted information in CSV format in an Excel direct. Then again it says do not add any clarifying information. Output must follow the schema above. I mean, language model doesn't understand, they hallucinate. So they're trying to add multiple times generate this prompt. And whatever examples we are giving in the prompt itself that this is the input and this is the expected output from that. So that's the inside magic. All it is trying to do is generate this prompt so that language models can easily extract information. So one thing I often do is monitor your cost. This is very important because if you are using any commercial models, you need to make sure how many tokens you are spending while you are creating the prompt, and it will also tell you the cost that for this particular prompt that we asked. I mean, the cost looks less, but when you try multiple prompts, it's like significant, and when you apply it on larger documents or larger data sets, it's much more than sometimes what you expect. So always make sure like you check the cost. Yeah, this is just a list design. And how many people are familiar with Pydantic? So it's basically a Python library which will make sure to validate the data. So you can just add Pydantic way of defining the class. Like you can have the same first name, last name, age, and you can have these validators which will tell that okay, first name should not be empty. And you can see on top like here we don't have any condition, but here we said that this can be optional, this can be optional. This way, if anything goes wrong, we get a validation message that, oh, the first name is empty because we are just throwing a sentence like he is just empty. So this can help you to validate like what's probably going wrong in your code. Yeah, so this is cool, but what are real world examples, right? And how many people are familiar with invoice parser or invoice parsing? It is generating like millions of dollars for multiple companies. There are companies from probably like 60 years back still working on that, and even though it looks simple, lot of people write regular expressions, and after that there are some model scheme, like there is a model called Donut or Layout LM, which is looking at your layout and trying to get the answer, but even those models are not able to get good performance, so still people use regular expressions, which is curious, definitely. So I generated a sample invoice. So it has a typical company address, bill and ship, and description, quantity, unit price and total of different things. I just have some random things there. And people also care about what was the final amount and what was the balance due, etc. So what we can do is we need not like create a big prompt, right? We can always like create small objects using code and pass it our entire input to find the answers. So I just used PDF Miner, open source library, which will extract the content from this invoice. Because these are open source and not commercial, the extraction is not great. For example, it extracted bill to Pepperpot Star Industries, and instead of going to Robo Street, it directly went to ship to Happy Hogan. So sometimes the extraction is not great, but even the extraction is not great. Sometimes like language models are good enough to understand the difference between what what address is for what. So here, similarly, we can create like invoice objects, then give some examples. More examples you give, it understands it better because you might have different types of invoices, and this can reduce the hallucination effect that can happen. So yeah, similarly, the second step is to create a chain, then predict, very simple. Then you can look into the prompt. It created something like what we have seen, and extracted the appropriate answer for the invoice. So this is what is present here. And similarly, you can create the objects for address. We have 3 different addresses. That's why we need to explicitly mention that many equal to 2, so that it puts in prompt that it can be multiple addresses that needs to be extracted. And after I created the chain, I got like 3 addresses. But let's say I am just interested in billing address, not all the addresses that are present here. So what this library also enables me to do is to replace, take the address schema that we already defined before, and replace the ID with billing address and change the description. This way, we can explicitly extract only billing address instead of all the addresses that are present. Similarly, for the product items, we define the attributes. There are 3 types of attributes, which is like text, number, and object. And we provide the examples, and we create the chain, and we just get the prediction of the model. So sometimes the interesting thing is, for example, if you take the bill schema, let's say I want to generate certain things. I do have the tax rate, which is like tax percentage, which is 10%. But what if I also wanted to know the amount of that, right? So I can, in description, I can actually explicitly mention the formula, like, okay, remove, like get the discounted amount, remove from the total, and multiply with the tax percentage. That's how you can mention it. So even though it extracts the certain information, it can also compute attributes and put it in appropriate format. So the last thing I want to quickly go to is nested objects. Let's say like after you create this small objects, you can also create a parent object which contains whatever we have seen, like invoice number, then billing address schema, product schema, and total bill schema. This way, the entire text gets extracted. And yes, always look at the cost. So now we are seeing for one invoice, you're spending like 0.003. But obviously, you want to test on larger data set and see, and also play with prompts. These are my initial prompts I used, but you can always change and add explicitly these prompts. So yeah, this is pretty much about the library. And let me conclude. So right now, I kind of used open source libraries, but you can always use commercial models for good extraction. Like you can go for AWS Extract. From my experience, it works much better. Or you can also use Azure Form Recognizer. The other thing you need to keep in mind is input token length. Like models have limited token length. But if you're taking the current model that I'm using, GPT 3.45 Turbo, it has like 4,000 token length. So if you want to create that nested structure, sometimes it might be very big. So you need to make sure that if you want to use other model, or if you want to break that into multiple chunks and extract explicit separately or not. Then because this is using LangChain, right? We can use not just OpenAI, but we can also use multiple big models. For example, MPT-7B, which has like 65,000 context length instead of 4,000. However, the issues of using non-commercial models is like you need to have a very good GPU to support and get in less time. Yeah, you can always also break the invoice into segments and try to extract content. always add more and more examples so that it hallucinates less. And we have seen also always monitor the cost. What you can also do is introduce human in the loop process because you can always ask language model to give confidence when it is trying to extract the text. I know again that might be generated and how we can rely on that is still a question. But if we can find a way or if we can see at least that this is in the same layout or something and we can get some confidence around that, we can have human in a loop whenever the confidence is less. We can ask people to review it and see if they want to change the prompts or add more examples to have less inconsistencies. Then definitely we need to have like verification steps. This way we can see if certain things are not getting extracted or extracting wrong. We can use Pydantic, but we can also use other libraries for that. Finally, all this library is trying to do is generate a prompt for you from the structure you have created. They continuously change their, it's an open source, so they continuously change their way how they make prompts. But you can always create your own version of code to extract the structured text. You do not rely on this library, but at the same time, you can see what updates they are going and having. All right, so this is a short talk, but if you have any questions, let me know.